This is a Mark 24 Spitfire, one of the last Spitfires ever built. And although there's only 10 years difference between this and the prototype, it's quite different. It's twice as big and twice as powerful. It's a complex piece of engineering with its strong and yet aerodynamic shape. It was designed on paper and built by hand, which begs the question, what can modern technology do to help restore machines like this?
If we're restoring a piece of an aircraft, first and foremost the question is going to be, do we have the drawings or a digital file that we can manufacture that part? If not, then we have to use methods such as what we're doing here is reverse engineering using scanners to produce the point cloud, the data, which we can then work from. So for example, if we look at this Merlin engine, if there's a particular casing or cover that we don't have any CAD drawings for, we can simply scan that item, we can create a digital image, and we can then put that digital image into CAD software, which allows us then to manipulate that information and produce files or produce engineering drawings to allow us to manufacture that part, either through traditional manufacturing or even now with metal 3D printing.
So back to our Spitfire and a man with a scanner.
What we've got is a FARO Focus S350. The laser is being pulsed out up to 350 metres in both directions. As that laser hits a surface, it gets a return, and that return is actually recorded data. Each point that it records has an XYZ position and an RGB colour. So when all that data is brought together through multiple scans, we end up with an entire point cloud, which can then be taken on for reverse engineering, or it can be used for digital archiving purposes. In this particular scenario, I've done around 20 scans. Each scan has overlap between them. I will take those back to the office, I'll process the data and join those pieces together, almost like a jigsaw puzzle.
Here we are, the combination of those scans, stitched together to produce a digital 3D model of the Mark 24 Spitfire. It may look a little rough around the edges because this model has not yet been fully processed. However, the information it contains is incredibly accurate and has only taken a matter of hours to produce. In a few weeks, we'll be returning to this project as we look at what physical elements can be created from this data and how that technology might be used on historical aircraft.